Example number 5. Factor the quadratic below. So let me go ahead and write the new polynomial here. This is equal to, we now have negative 0.4 x squared minus 4.4x minus 11.2. And here, as you can see, we are dealing with decimals, okay? But let's do the following. Imagine for just a couple of seconds that instead of dealing with decimal numbers here, that we are dealing with integers, okay? Imagine that instead of having here negative 0.4, imagine that we instead have the following coefficient. Imagine that instead of having here this coefficient, negative 4.4, sorry, imagine instead that we have 44, and imagine that instead of having this number here, 11.2, imagine that instead we have 112. Now take a look at the following. 4 is a number that is divisible by 4. The same can be said of 44, and also 112, you can verify that with the calculator, is also a number that is divisible by 4, which means that negative 0.4 is a factor of all three terms. Or you can also say the following, that all the coefficients here on this polynomial, all of the coefficients that we have here, they're all divisible by negative 0.4. So let's go ahead and factor negative 0.4 from all three terms here, from here, here, and here. And now we have the following, that this polynomial is going to be equal to negative 0.4 times x squared plus 11x plus 28. You can verify that these coefficients are correct by simply multiplying negative 0.4 times x squared. You can obtain negative 0.4 x squared. Negative 0.4 times 11x, you're going to be able to obtain negative 4.4x. And if you multiply negative 0.4 times 28, you will obtain negative 11.2. So now all we have to do to complete our solution for example number 5 is factor this trinomial that we have here inside the parentheses. So let's go ahead and factor this trinomial using trial and error that we already saw on example number 4. So let's go ahead and do that. So now we have the following, that this is going to be equal to negative 0.4. Let's open two parentheses and begin the process. To obtain x squared, we can use x times x. And to obtain 28 as our last number here, and a coefficient of x equals to 11, let's find a combination of two numbers, which when multiplied will be equal to 28, but if we add, then their addition will be equal to 11. So let's find those two numbers. Let's say, let's try the following combination: 7 and 4. Let's take a look and see if this works. If we multiply 7 times 4, okay, that's equal to 28. So far so good. If we add 7 and 4, that's equal to 11. Alright, so we found our combination. So we were lucky. So we're going to use 7 and 4. So now we have the following, that this polynomial here is going to be equal to negative 0.4 times x plus 7 times x plus 4. And this completes our solution for example number 5.